A gas expander reduces the pressure of a gas while converting its energy into useful mechanical work. A gas expander reduces the pressure of a gas while converting its energy into useful mechanical work. By the end of this video, you'll be able to model an expander in HYSYS and calculate its expansion efficiency and outlet temperature. Gas enters the expander at 25 degrees Celsius, 20 bars, and the flow rate of 100 kg/mole per hour. The expander operates at 30% efficiency. The gas exits at a pressure of 5 bars, and the outlet temperature is to be determined. Open Aspen HYSYS software. Click on New button. Click Add to open the component list. Now, let's add the components. Select methane, ethane, and propane from the list, then click Add. Select the fluid package option and click Add to include a property package. From the list, scroll down and select Peng-Robinson. Finally, click Simulation to add the expander and the material streams. Add a material stream by dragging the blue arrow from the object palette. Double-click the stream to enter its properties and name it Feed. Set the temperature to 25 degrees Celsius, the pressure to 20 bars, and the molar flow rate to 100 kg/mole per hour. Next, open the Composition tab and enter the component fractions as shown in the table. After defining the composition, click OK and close the Material Stream window. Drag the expander icon onto the flowsheet. Double-click the expander icon to open its window and rename it Expander. In the Inlet field, select Feed. In the Outlet field, enter Out to create a new material stream. In the Energy field, enter Work to create a new energy stream. Now, it can be observed that new material and energy streams have been created. Switch to Parameter tab and set the adiabatic efficiency to 30%. Next, open the Worksheet tab. A yellow status bar indicates that the expander is not fully defined. Go to the Conditions page and set the pressure of the outlet stream to 5 bars. The status bar turned green, confirming that the expander is fully defined and results are available. The expander's outlet temperature is -6.19 degrees Celsius. In this case, the expander outlet temperature was calculated at 30% efficiency. The result shows that the gas expansion decreases temperature. At this low efficiency, the gas temperature was decreased by 31.19 degrees Celsius. At 70% efficiency, the temperature change is even higher. This clearly demonstrates that the lower expander efficiency leads to lesser decrease in the temperature of outlet gas.